In previous video, we have seen how to determine the solution of differential equation of second order. In that, we have seen there are two types of second order differential equation. First one, that is homogeneous differential equation, and second one is a non-homogeneous differential equation. If you have not gone through that video, please check the video on my channel, or I am just giving the link for that video in the description. Please go and check that. So in non-homogeneous differential equation, we have just gone through one type, that is if the value of r is equal to e to the power plus or minus ax. I would like to consider one more example related to this type, that is if the value of r is equal to e to the power plus or minus ax. Let us consider an example, d square minus 5d plus 6y equal to sine of hyperbolic x. Now this sine of hyperbolic x can be written as e to the power x minus e to the power minus x by 2. Substituting the corresponding value of sine hyperbolic x, we can rewrite this equation as d square minus 5d plus 6y equal to e to the power x minus e to the power minus x by 2. Now we can find the particular integral solution for this e to the power x and this function, that is e to the power minus x, separately. Now I am calling the solution for e to the power x as ypi1. So the solution, we know how to find the solution. It is given by 1 upon f of d, that is d square minus 5d plus 6 into e to the power x. Now substitute the value of a in place of d, then we find that it is equal to 1 minus 5 plus 6. If we sum the denominator, then we find that the denominator is not equal to 0, then the solution will be e to the power x by the sum of the denominator after substitution. So 6 plus 1 7 minus 5, that will be equal to 2. So the solution for e to the power x is equal to e to the power x by 2. Similarly, for e to the power minus x function, I am calling the solution as ypi2. Similarly, find the solution or particular integral solution of e to the power minus x. So for e to the power minus x function, we have the value of a equal to minus 1. Substitute the value of a equal to minus 1 in place of d. We will find that d square minus 1 square is equal to 1 minus 5 into minus 1 is equal to minus 5. So minus 5 into minus 1 equal to 5 plus 6 e to the power minus x. So the total sum of the denominator is not equal to 0. So the solution will be e to the power minus x by 12. So sum this corresponding different solution, we will get the final solution of our given differential equation. So y will be equal to, so don't forget this 2 which is written over here. So y will be equal to 1 upon 2 into e to the power x by 2 plus e to the power minus x by 12. Or I can rewrite that solution as 1 of e to the power minus e to the power x by 4 plus e to the power minus x by 24. So this will be the final solution of a given differential equation. If we are provided with the function r whose value is cos of hyperbolic x, then replace this cos hyperbolic x as e to the power x plus e to the power minus x by 2 and find the corresponding solution, same as that of we have determined the solution for sine of hyperbolic x.
So the next type of differential equation is of type if the value of r is equal to sine bx or cos bx. We know that if the value of r is not equal to 0, then we find the solution of such differential equation by particular integral type, that is ypi equal to 1 upon f of d into r. Now in this case, that is if the value of r is equal to sine bx or cos bx, then simply substitute the value of d square equal to minus b square in denominator. We know the differential equation, that is f of d is of form d square plus something xd plus y equal to something r. And if it is of such type, then simply substitute the value of d square equal to minus b square and check whether the value of denominator is equal to 0 or not. If it is not equal to 0, then the value of ypi after substitution itself will be the solution of such differential equation. And if the value of denominator is equal to 0, then simply differentiate the denominator and multiply numerator numerator with x. You will get the solution. And once again substitute the value of d square equal to minus b square and check whether the denominator is equal to 0 or not. If it is equal to 0, then repeat this procedure, and if it is not equal to 0, then the value itself is the solution of that differential equation. Now let's try the example of such type. Example 1, b square plus 4y equal to sine 2x. Over here, the value of b is equal to 2. So d square will be equal to minus b square, that is equal to minus 4. So the solution will be given as ypi equal to 1 upon f of d. F of d, the value of f of d is equal to d square plus 4. So we will directly substitute over here into sine 2x. Now substitute the value of d square equal to minus 4 and check whether the denominator is equal to 0 or not. We can simply observe that if we substitute d square equal to minus 4, then we get denominator equal to 0. So minus 4 plus 4 sine 2x. So we know if denominator is equal to 0, then we simply differentiate the denominator and multiply numerator by x. Now let's do the calculation by differentiating. So after differentiation we get 2d and sine 2x and simply multiply with x on the numerator after differentiation. So we get something x upon 2d into sine 2x. But we can see that there is one extra variable d. So we need to remove this d. So just simply multiply and divide by d on numerator and denominator. We get something x upon 2d square into d sine 2x. So after substituting the value of d square equal to minus 4, we get x upon 2 into minus 4 into d sine 2x. So d is nothing but a differentiation. So we get x upon minus 8 and differentiate sine 2x, we get 2 cos 2x. So this 2 get cancelled and we get the final solution as minus x upon 4 cos of 2x. So this will be the final solution of our given differential equation. Let us consider one more example to understand this type of example very clearly. Second example, d square minus 2d plus 1y equal to cos of 3x. Over here the value of b is equal to 3. So the value of d square will be equal to minus 9. So let's start our solution. So solution is given as ypi equal to 1 upon f of d, that is d square minus 2d plus 1 cos of 3x. So let's substitute the value of d square equal to minus 9. We have minus 9 minus 2d plus 1 into cos of 3x. So if I substitute, I found the denominator equal to minus 2d minus 8 into cos of 3x. So if I check whether the denominator value is equal to 0 or not, then I can say that the value of denominator is not equal to 0. So if the value of denominator is not equal to 0, then we need to multiply the numerator and denominator with the conjugate of denominator. First of all, let's arrange this equation as minus 1 upon 2. I'm just taking minus 1 upon 2 common. Then I get 1 upon d plus 4 into cos of 3x. So as we have done in our complex where we are considering one as a real part and we are considering another as a imaginary part. So over here, consider this as a d part as a real part and the numerator number part as a imaginary part. Then find the conjugate. So conjugate will be equal to d minus 4 for d plus 4. So simply multiply by conjugate on numerator and denominator, then we get minus 1 upon 2 into d minus 4, and if I multiply by d minus 4 on denominator, then I get d square minus 16 cos of 3x. So if I substitute d square equal to minus 9, then I get minus 1 upon 2 into 1 upon d square minus 9 minus 16, which will be equal to minus 25. So this minus minus get cancelled, and simply operate this d minus 4 separately on cos 3x, then we have minus 1 upon plus 1 upon 50 into d cos 3x minus 4 cos 3x. So the solution will be 1 upon 50 differentiation of cos 3x will be equal to 3 sin 3x, or sorry, minus, I forgot the minus sign over here, minus 4 cos 3x. So this will be the solution of our given differential equation, or I can rewrite this as minus 1 upon 50 3 sin 3x plus 4 cos of 3x. So in this way we can determine the solution of our given differential equation. Let us consider one more example. D square plus 4d y equal to cos of x. So over here the value of b is equal to 1. So d square will be equal to minus 1. So the solution will be 1 upon d square plus 4d cos of x. After substituting the value of d square equal to minus 1, I get 4d minus 1 cos of x. So just over here we can see that at the denominator there is no natural number, or there is a presence of one variable, that is d. Then simply multiply and divide by conjugate of denominator, then we have, so over here the conjugate will be 4d plus 1. So after multiplication I get 4d plus 1 upon 16d square minus 1 cos of x. So over here, simply operate 4d plus 1 on cos x separately and find the corresponding denominator. So after substituting the denominator value of d square equal to minus 1, then we get minus 16 minus 1 into 4 of d plus 4d cos of x plus cos of x. I'm just operating this 4d plus 1 separately on cos of x, then I get minus 1 upon 17 into 4 differentiation of cos is equal to minus sign, so minus 4 sin x plus cos of x. If I rearrange this equation, then I can write 1 upon 17 4 sin x plus cos of x. So in this way we can find the differential equation, or in this way we can find the solution of our given differential equation in this manner. Practice few example at your home of such type. First one, that is d square plus a square y equal to cos of x. The solution for this type of differential equation is given by 1 upon 2a x sine of x. Then second type, d square plus a square y equal to sine of x. Over here the solution is minus x upon 2a cos of x. So just try to solve this two example and check whether you are getting the solution as something like this and like this. Just practice this type of differential equation and check your solution somewhere. If you practice this type of differential equation, then definitely you will master this differential equations and you will be able to solve this type of differential equation quickly in your exams, specifically in your net exams or set examination. This type of differential equation mostly appear in your GATE examination or net examination, because for net they definitely ask you at least one differential equation. So practice your differential equations. I guess this type of differential equation they ask you for 3.5 or 5 marks. So practice as much as you can. So that's it for today's lecture. Thank you.